Welcome to you all. By name is Irene Praise, and I'd like to take this honor to present to you Diary AI, which is the final products, commercial products for our AI projects. And I'd like to start with the problem. And obviously, the initial problem that we had here was the one that we noticed was inefficient feed formulation and unpredictable milk yield, which reduce productivity and profits for smallholder farmers. And obviously, it is not only feeds that are nutrients that determine milk yield, but farmers, mostly small scale farmers, usually have no idea or knowledge about the importance of nutrients, and they just feed their livestock with whatever they find or whatever they have seen their their fellows feed their animals, which is not efficient and effective. And why would we consider using AI? The traditional rule-based feeding models ignore dynamic biological and climatic and market variability. So here in our AI, we also included climate conditions. Yeah. So as you will see in the deployed product, that when a person, uh, when uh, when a user inputs the the details of the cow, the feeds, and the climate, the temperature condition, uh, if, uh, an efficient prediction is made, as well as proper feed formulation, which is optimized by our models. And the solution is that we came up with the Dairy Nutri AI, which I'm presenting, which is an artificial intelligence system that predicts feed efficiency using milk yield, as well as suggests optimized feed formulations for the user. And we combined Bayesian hierarchical time series model as well as gradient boosting to help in predicting milk yield and efficiency. And for the feed formulation and optimization, we used the mixed integer linear programming model, which we aimed at minimizing cost, but also maximizing nutrients according to the requirements of the given livestock or cattle. Here we're talking about dairy cattle in this situation. And for our base code, for our backend, we used Python mainly. For all our models, we use different libraries, Matlib for visualizations, and we deployed. For deployment, we launched the system as a web server on render.com for now, so that we can be able to access it using any device as long as you have the link with a responsible web page user interface, which is easy to interpret and use. Um, and Here, as you can see, our pipeline is that where after data collection and the data that is input into the system, the data is processed by our models, and then there is model training. Actually, right now the models have been trained. So in the prediction engine, which is categorized of, which is composed of the Bayesian hierarchical time series and the gradient boosting model. A prediction is made, and for the next is the MILP feed optimization, which computes the least cost and also a nutrient balanced feed formulation, combining different feeds like grass silage, um, maize bran, etc. And the user's inputs, when the user the inputs into the user interface and prompts it, it gives feedback, and we we actually plan on using that data, and the data that is input is used for continuous improvement and updating of the models. And for revenue streams, we plan on deploying it as a mobile application or a software as a service, whereby users subscribe, make it a subscription-based AI, or we can have custom formulation services for cooperatives. We can just, instead of giving them the application ourselves, we have agents who will move to cooperatives and do the formulation for the different cooperatives, and also ingredients procurement optimization, where some companies which work with feeds for livestock can use our AI to determine optimal feeds to give different livestock and different nutrient compositions to use as they are manufacturing their new products. And we want to have cloud hosting and model training, uh, and as well as field data collection, where you can have agents going to different farms and getting real-time data, getting data from the source instead of basing on a data set, which enables keeping up with different trends. Yeah, and we plan to expand to poultry model that focuses on egg production to include it as well. We also want to integrate on-farm sensors for better data collection and daily ration updates on the mobile interface, so that when a user has these on-farm sensors on his farm connected to the phone, uh, data is easily input uh, for the models to get better predictions. And here is a simple demonstration prototype of our working deployed system. Yeah, let me play it for you. That was the demo, and thank you for listening. You can reach me on this is my email. Yeah.